So here we have our sort of general solution for this freeway problem. So our answer, well, not necessarily our answer, but the answer is not a specific number. It's not a yes or no. It's not this one or that one. Our solution is a dynamic solution set. That is, it changes based upon the variables that are present, based upon the values of the variables that are present. So the variables are all explained in detail in the italicized font. So on the left-hand side, we have our expression for the 10 freeway. We're just looking at the number of cars that pass through some interval on the 10 freeway. So, well, for the totality of the 10 freeway. So when we look at start to finish, we'll know R sub t, number of cars passed on the 10 freeway. That's all R sub t is saying. Now we have this question mark equals question mark. That isn't just summary saying, well, this could be less than or equal to or greater than. That's all it means. The question mark equals question mark. It's just saying that for sure it could be less than or greater than or equal to. It's not set in stone. The next portion, now we have these crazy parentheses. These parentheses are actually very simple if you can take the time to really think about them. First off, let's identify what y is. Y is a scalar multiplier, greater than 1, representing how much faster the 210 is compared to the 10 freeway. So we're talking about how many more cars are getting passed on the 10 freeway. Excuse me, how many more cars are getting passed on the 210 freeway compared to the 10 freeway. D sub 4 is the percentage of the time where the 210 freeway is 4 lanes, okay? And we're going to multiply that by the number of cars that get through on the first lane for the 10 freeway, plus the number of cars that get through on the second lane for the 10 freeway. The same for the third lane, the same for the fourth lane. The reason we're doing this is because we know this, remember, the right-hand side is an expression for the 210 freeway. And for this first expression, this first mini expression right here, it's talking about each of the lanes for the 210 freeway. So for example, if we take y times d sub 4 times r sub 1, and let's just look at that. That's an expression for how many cars, when you're looking at the 210 freeway, when there's 4 lanes, are getting through in the first lane specifically. Y is the number of how many more cars are there than the first lane on the 10 freeway. Then D sub 4 says, well, it's not doing that for the whole time. D sub 4 says you're only doing that for, say, 20% of the time. You're only getting that number of cars through for 20% of the time or 30% of the time. And then the same logic applies for R sub 2, R sub 3, and R sub 4. If we take y times D sub 4 times R sub 2, continuing the distribution, that's talking about an expression for the second lane on the 210 freeway. Y says how much faster is the traffic flowing on the 210 freeway than the 10 freeway. That is, how many more cars are going through on the 210 freeway as compared to the 10 freeway. So we can now move on to kind of the second expression. And the second expression is very similar. It's just that for the first one, we knew that all of the lanes were going faster than the 10 freeway. However, with the second expression, when there's 3 lanes, it changes a little bit. So we have the D sub 3 outside. Again, that's talking about that you're only going to be doing this for the section of the 10 freeway that is 3 lanes. That 3 lanes does not encompass the whole thing. It's only for a certain percentage of time. So we have D sub 3 times y, y times r sub 1. So that first term is going to talk about how fast the 210 traffic is flowing in the first lane when there are 3 lanes, right? So we already talked about the D sub 3. The Y says that it's going faster. It's going Y times faster than the traffic it's going Y times faster than the traffic on the 10 freeway. Similarly, when we examine D sub 3 times X times R sub 2, D sub 3 represents that fraction of time that you're on the 3-lane track. X says that you're going X times slower on the 210 as compared to the 10. So an example, if the traffic on the 10 freeway was flowing at, say, maybe 70 miles an hour, well, then the traffic on the 210 freeway might be flowing at 60 miles per hour. It's some part less. It's just going a little bit slower. I talked about a speed, but it's the same thing as conceptually as the number of cars. So if there were 70 cars going through on the 10 freeway in a given interval, then on that same interval of time, there might be 60 or 50 or 40, a smaller amount than what was on the 10 freeway. That's all that side states. And similarly follows the X times R sub 3. And then the exact same thing follows for the last expression. We have X times D sub 2 times, let's look at the first term, X times D sub 2 times R sub 1. This term talks about the speed of the first lane on the 210 freeway when there are only 2 lanes available to drive on. So the X says, okay, both of these terms are going to be some measure slower than the traffic on the 10 freeway. And so R sub 1, that's the number of cars that are getting through the 10 freeway on any interval. So it's just talking about, again, how many cars are getting through on the 210 freeway. However many cars are getting through on the first lane, it's going to be X times slower than that. And that's the totality. Once you start getting information for these things, once you know, okay, well, we're talking about a 10-mile strip of land, and we know for 3 of those miles, we're going to have 4 lanes. So we can say D sub 4 is 3 over 10. It's going to be 4 lanes 30% of the time. Then we might say, okay, well, D sub 3, we might also have it be 3 miles of land out of this 10-mile strip. So then we'll say, okay, well, D sub 3 is 3 over 10. Similarly, for D sub 2, well, if we did 3 and 3, we now have to do 4. So then D sub 2 could be 4 over 10. So we know that there's this relationship that exists when we'll have like 4 out of 10% of the time. 4 out of 10% of the time. That's not right. 4 out of 10 of the time. It's almost like probability. It's kind of wonderful in the way that it works like that. R sub 1, R sub 2, R sub 3, R sub 4. Those are simply just rates. We're just finding out how many cars might pass on the 10 freeway in a specific interval. And we're saying that this relationship is set up such that the rate of the 10 freeway and the 210 freeway are interlinked. They're dependent on one another. And that kind of makes sense in real life too. The speed of the 210 freeway depends on the speed of the 10 freeway and vice versa. Because if there's a lot of traffic going through, if everybody's going through the 10 freeway, then the 210 freeway is going to be pretty deserted. And the opposite, if everybody's going down the 210 freeway, then there's going to be more spaces available on the 10 freeway. So that's a summation of kind of a explanation of what's going on here mathematically, a very in-depth explanation.